Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So let's get going. Problem solve y double dash plus y dash plus 6y equal to e power minus 2x secant square x of 1 plus 2 tan x, or d square plus 5d plus 6 into y equal to e power minus 2x secant square x of 1 plus 2 tan x using variation of parameters method. So here we are given a differential equation of order 2. Given differential equation, y double dash plus 5y dash plus 6y equal to e power minus 2x secant square x of 1 plus 2 tan x, or we can write y double dash as, consider the given first equation as equation 1. Okay, we can write y double dash as d square y by dx square plus 5 into write y dash as dy by dx plus 6y equal to e power minus 2x secant square x of 1 plus 2 tan x. Here both the equations are same. The second equation is the first equation in operator form. Okay, first equation in operator form is our equation. The second equation, both the equations are same. Well, now we can write d square y by dx square as capital D square y plus 5 into write dy by dx as dy plus 6y equal to e power minus 2x into secant square x of 1 plus 2 tan x. Now take y common from all the three terms of LHS. We'll get d square plus 5d plus 6 into y equal to e power minus 2x into secant square x of 1 plus 2 tan x. Consider as equation number 2, which is in operator form. Say f of d into y equal to function of x, where f of d equal to d square plus 5d plus 6 and r of x is the RHS part. Now we'll find the solution of equation 1 and 2 using y equal to, the general solution of 1 and 2 using y equal to yc plus yp. We'll find yc using the auxiliary equation, and later using the auxiliary, using the complementary function, we'll find yp. Let's find yc using the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 5d plus 6, right? Let's replace differential operator d with m, so that we'll get f of m equal to m square plus 5m plus 6. Then f of m equal to 0 becomes m square plus 5m plus 6 equals to 0, which is our auxiliary equation. Now we need to find roots to this equation. We'll get m square plus 2m plus 3m plus 6 equals to 0. From this we'll get m times m plus 2 plus 3 times m plus 2 equals to 0. We can write this as m plus 2 into m plus 3 equal to 0. From this we'll get m equal to minus 2 minus 3. Just equate each factor to 0. From m plus 2 equals to 0 we'll get m equal to minus 2, and from m plus 3 equals to 0 we'll get m equal to minus 3. Therefore the roots are real and distinct. Right? We know that when two roots are real and distinct, say m1 and m2 are real and distinct, then yc looks like yc equals to one constant into e power 1 root into x plus another constant into e power another root into x. Let's now write the complementary function. Yc equals to c1 e power minus 2 into x plus c2 into e power minus 3 into x. From this we'll get yc equals to c1 e power minus 2x plus c2 e power minus 3x. Okay, now using yc we'll write yp. Let yp equal to, let's just replace c1 and c2 with functions of x, a and b. That is, we are changing the constants or parameters with functions of x, so that we'll get yp equal to a e power minus 2x plus b e power minus 3x, right, where a and b are functions of x. Also, we can compare yc with c1u plus c2v or yp with au plus bv, so that we'll get u and v, where u is e power 2x and v is e power minus 3x. See, u equal to e power minus 2x, v equal to e power minus 3x, u equal to e power minus 2x, v equal to e power minus 3x, right? U equal to e power minus 2x and b equal to e power minus 3x, and we'll find a and b using formulae. A is given by minus v into r of x by u v1 minus v1 into dx, and b is given by integral u into r of x by u v1 minus v1 into dx. Notice we are having u v1 minus v1 in both the formulas, so let's begin with u v1 minus vu1, and later we'll find a, b and yp, and finally we'll write the general solution using y equal to yc plus yp. Here v1 is nothing but derivative of v with respect to x, minus v into u1 is nothing but derivative of u with respect to x. We have u e power minus 2x into derivative of e power minus 3x with respect to x minus v into the derivative of u with respect to x. This gives us e power minus 2x into derivative of e power minus 3x with respect to x is minus 3 e power minus 3x minus e power minus 3x into derivative of e power minus 2x with respect to x is minus 2 e power minus 2x, which gives us minus 3 e power minus 3x e power minus 2x plus 2 e power minus 3x e power minus 2x. Since we know that e power minus 3x into e power minus 2x equals to e power minus 3x minus 2x, which is e power minus 5x, this gives us minus 3. Just replace e power minus 3x into e power minus 2x with e power minus 5x, so that you'll get minus 3 e power minus 5x plus 2 e power minus 5x. Minus 3 e power minus 5x plus 2 e power minus 5x gives minus e power minus 5x. Therefore, u v1 minus v1 equal to e power minus 5x minus e power minus 5x. Okay. Now coming to a is given by integral minus v into r of x by u v1 minus vu1 into dx, which is equals to minus integral v is e power minus 3x into r of x. Let's write minus inside the integral, that's not an issue. into r of x is e power minus 2x secant square x of 1 plus 2 tan x by uv1 minus vu1 is minus e power minus 5x into dx. This gives us integral minus e power minus 3x into e power minus 2x secant square x of 1 plus 2 tan x by minus e power minus 5x into dx. This is equals to integral minus e power minus 3x into e power minus 2x is e power minus 5x secant square x of 1 plus 2 tan x by e power minus 5x into dx, right? So here e power minus 5x gets cancelled, or minus e power minus 5x gets cancelled. Then we'll get a equal to integral secant square x of 1 plus 2 tan x into dx. Let f of x equals to 1 plus 2 tan x, then f dash of x is derivative of 1 with respect to x is 0 plus 2 into derivative of tan x is secant square x. So therefore f dash of x is secant square x, and we have the formula integral f dash of x into f of x dx equal to f of x whole square by 2, which comes from integral f dash of x into f of x whole power n dx equal to f of x for n plus 1 by n plus 1, right? For n not equal to minus 1. See, other than n equal to minus 1, the formula is applicable for all n. Okay, here in our case for n equal to 1, we'll get f dash of x into f of x dx equals to f of x whole square by 2. Simply apply n equal to 1, then you'll get f of x for 1 plus 1 by 1 plus 1, which is f of x whole square by 2. Right? Now, we need a 2 here, right? Because f dash of x is 2 secant square x. So what we'll do is, we'll just multiply and divide 2 secant square x. Since 2 by 2 is 1, which is nothing but the same. Now take 1 by 2 common, outside the integral, then you'll get 1 by 2 into 2 secant square x of 1 plus 2 tan x into dx. This gives us 1 by 2 integral f dash of x into f of x dx is f of x whole square by 2. F of x is 1 plus 2 tan x whole square by 2, which gives us 1 by 4 of 1 plus 2 tan x whole square, right? Therefore a equal to 1 by 4 of 1 plus 2 tan x whole square. Let's now find b. b is given by integral u into r of x by uv1 minus v1 into dx. That u is e power minus 2x into r of x, e power minus 2x secant square x of 1 plus 2 tan x by uv1 minus vu1 is minus e power minus 5x into dx. This is equals to minus integral e power minus 2x into e power minus 2x secant square x of 1 plus 2 tan x by e power minus 5x into dx. This is equals to minus integral e power 2x, e power minus 2x into e power minus 2x is e power minus 2x, which is equals to e power minus 4x, right? So let's replace this with e power minus 4x into secant square x of 1 plus 2 tan x by e power minus 5x into dx. In the next step, you can write e power minus 5x as 1 by e power 5x, or we can split the total fraction as the numerator part into 1 by denominator part. Okay, it's up to you. So I'll just write e power minus 5x as 1 by e power 5x. Right? Which gives us minus integral 1 by e power 5x is e power 5x, right? So you'll get e power 5x into e power minus 4x secant square x of 1 plus 2 tan x into dx. If in case you want to separate the fraction, just split the fraction as minus integral of e power minus 4x secant square x of 1 plus 2 tan x into 1 by e power minus 5x. 1 by e power minus 5x is e power 5x. So again you'll get e power 5x into e power minus 4x secant square x of 1 plus 2 tan x into dx. So you'll get the same thing. Equal to minus integral e power 5x into e power minus 4x is e power 5x minus 4x, which gives e power x, right? We can replace it with e power x. You'll get e power x into secant square x of 1 plus 2 tan x into dx. This gives us minus integral e power x into, now multiply these two terms with secant square x, we'll get secant square x plus 2 tan x secant square x into dx. Now let secant square x equals to f of x. We know that 1 plus tan square theta equal to secant square theta. Just replace secant square theta with 1 plus tan square theta, then we'll get f of x equals to 1 plus tan square x. Now find f dash of x. F dash of x is equal to derivative of constant with respect to x is 0 plus derivative of a tan square x is 2 tan x into derivative of inner derivative, that is secant square x. Derivative of tan x is secant square x, which gives 2 tan x secant square x. And we know that integral f dash of x, e power x into f of x plus f dash of x into dx equals to e power x f of x, right? See, the integrand is of the form e power x into f of x plus f dash of x, right? So we can apply the formula, then we'll get minus e power x into f of x, that is secant square x. Therefore b equal to e power x secant square x, minus e power x secant square x, right? And also here we can find the derivative of tan square x using chain rule. Let's find f dash of x, that is tan square x, derivative of tan square x using chain rule. Okay, let y equal to tan square x, or we can write it as tan x whole square. Now we are going to apply chain rule. Let tan x equals to u, right? Then y equal to, just replace tan x with u, you will get y equal to u square. Now we are going to apply the chain rule. Dy by dx equals to
dy by du into du by dx. Now we need to find derivative of y with respect to u and derivative of u with respect to x. So we are having y equal to u square. From this we can find dy by du, right? We have y equal to u square. Now differentiate on both sides with respect to u. From this we'll get dy by du equal to derivative of u square with respect to u is 2u. And we have u equal to tan x. Let's differentiate u with respect to x. If u equal to tan x, differentiate on both sides with respect to x. Then we'll get du by dx equals to derivative of tan x with respect to x is secant square x. Now substitute dy by du and du by dx here. We'll get 2u into secant square x. Again substitute u. We'll get dy by dx equals to 2 into u is tan x into secant square x, right? So therefore derivative of tan square x is 2 tan x into secant square x. From this we'll get f dash of x equals to derivative of 1 with respect to x is 0. Derivative of tan square x is 2 tan x secant square x, right? From this we got f dash of x equals to 2 tan x secant square x. Now coming to b. In b we are having minus integral e power x of secant square x plus 2 tan x secant square x dx, right? We can apply the formula integral e power x of f of x plus f dash of x dx equals to e power x of f of x. Here we have f of x is secant square x and f dash of x is 2 tan x secant square x. By applying the formula, we'll get minus e power x into f of x, which is f of x is secant square x. So finally, we'll get b equal to minus e power x secant square x. See? We can apply the formula simply, which is equals to minus e power x f of x. Just substitute f of x. Then we'll get b equal to minus e power x secant square x. Now, coming to yp, yp is given by a e power minus 2x plus b e power minus 3x. Just substitute a and b here. We have a 1 by 4 of 1 plus 2 tan x whole square into e power minus 2x plus b minus e power x secant square x of e power minus 3x. This gives us 1 by 4 e power minus 2x of 1 plus 2 tan x whole square plus into minus minus e power minus 3x into e power x secant square x. This gives us 1 by 4 e power minus 2x of 1 plus 2 tan x whole square minus e power minus 3x into e power x can be written as e power minus 3x plus x, which gives us e power minus 2x, right? Now just replace e power minus 3x into e power x with e power minus 2x into secant square x, which is our required yp. Now we got yp and already we have yc. Let's now write the general solution using y equal to yc plus yp. Therefore, the general solution is given by y equal to yc plus yp. Just substitute yc and yp here. Then we'll get y equal to yc c1 e power minus 2x plus c2 e power minus 3x plus yp a e power, that is, 1 by 4 e power minus 2x of 1 plus 2 tan x whole square minus e power minus 2x secant square x. This completes the problem. So this is all for now. I hope you'll understand. We'll see you in the next video. Until then, bye bye. Thank you.